Hi, I'm Sean Michael Reagan for Cool Tools, and in today's video, solder seals. These are single-use connectors for joining two wires together at their ends. Each one has three essential parts. First, there's the outer wrapper, which is a piece of clear heat shrink tubing that insulates the finished splice electrically. Second, about a quarter of the way from each end is a dot of hot melt glue that seals the joint against water and other unwanted liquids and gases. Finally, in the middle, there's a little donut of low melting point solder with a flux additive that helps it bond to the conductors. All three parts are heat activated at a temperature of about 285 degrees F, so you don't need any unusual tools to install them. Here, for example, I'm just using a butane lighter. Now, there are a lot of ways to join two wires end to end, but I think these little guys have all the other options beat. I first read about them in a post on the Cool Tools blog by Chuck Davey about a year and a half back, and I have been a convert ever since. Unlike crimp-type connectors, which are designed for stranded wire, and IDC-type connectors, which are designed for solid wire, solder seals work equally well on stranded wire, solid wire, or a combination of both. A complete solder seal is not much wider than the wires that go into it, which is extremely handy if you need to run a spliced wire through a narrow channel or around a tight corner in an enclosure. They're also highly waterproof. Here I've got a bit of salt water in a petri dish with a multimeter set to measure resistance. I can clip the other probe across both ends of a splice I want to test, then dunk the splice and see how long it takes for the water to reach the conductors. When that happens, we should see the resistance fall as current starts to flow through the liquid. We'll start with wire nuts. The resistance falls immediately because the water can just flow right in. Now a crimp connector. This one takes a bit longer, but after a little more than 10 seconds of immersion, there, water has penetrated to the splice. Here's a joint I soldered and sealed with heat shrink tubing myself. It's more waterproof than either crimps or wire nuts, but it still only takes about 3.5 minutes for water to infiltrate the splice. Now, here's a solder seal. After 10 minutes, my multimeter gives up and turns itself off to save batteries, and we still haven't seen any change in the resistance at all. If water does get into the splice, or if it should fail for some other reason, the fact that solder seals are optically clear means it's possible to inspect the connection visually, which can potentially save a huge amount of time when you're troubleshooting and looking for that one bad connection out of several dozen. About the only drawback with these things is that they are relatively expensive. Assuming you're buying a 300-piece assortment, wire nuts will run you about 4 cents a piece. Crimp connectors will cost you about 5 cents a piece. IDC connectors will run about 6 cents a piece, while solder seals come in at a whopping 13 cents a piece. If you've got professional work or a project that requires a whole bunch of splices, this could be a deal breaker. But if you're a maker or a handy homeowner who just needs to splice wires for an occasional project or repair, I think the advantages of solder seals more than make up for the modest additional unit cost. Okay, thanks for watching. As always, you'll find affiliate links in the description field below the video. We'll see you next time.